It's Algebra 2 using the quadratic formula and the discriminant. We're solving equations using the quadratic formula. Use them in real life situations. We won't do the fallen object checkpoint problem, but it does begin on page 291. First thing is the discriminant of a quadratic equation. The quadratic formula is negative b, remember this symbol right here, plus or minus the square root of b squared minus 4 times ac, and all of that is over 2a. The discriminant is just the part that is under the radical. So the discriminant is just that part of it. Okay, there's a reason why we use the discriminant, and when we look at example number 3 and 4, we'll see why. Okay, again, there's the quadratic formula based on, this is another way to solve for quadratics. It's another way to solve for anything that says x squared, any kind of equations with x squared. We've learned a couple of different ways so far. One of them is to undo it by factoring it. If you have something that you can factor to c in order to get the b value. The other way we learned last week was completing the square. Remember, in order to complete the square, you have to move the values over and find a new value for c, and then move the other value back over. This is just a third method using the quadratic formula. This formula works for every quadratic equation. It's not the best method to use, however, but it is the most reliable method. If you get stuck on some of the problems, you can always resort back to this. Again, like I mentioned earlier in class, the only mistakes people make with this stuff is they plug things in the wrong position. They leave a negative off or add a negative that doesn't belong, or they make a mistake following the order of operations, thinking they have to do one thing before they do the other. But it is the negative value of b plus the square root of b squared minus 4ac over 2a, and the negative b minus the square root of b squared minus 4ac over 2a. So it's like working, this symbol right here is like working the entire thing twice. One of them plus, the other one minus. So here's example number 1. It says 3x squared minus 3x minus 5 is equal to 0. You know that this is a, this is b, and this is c. The first thing you want to check is make sure it's in standard form. Make sure the thing that's multiplying by x squared is first, the thing that's multiplying by x to the first power is second, and then the thing without a variable at all is third. The next thing you want to check is you want to make sure that it is equal to 0. If it's not equal to 0, you have to move over whatever's on that side, and we'll see one like that in a minute. So all you need to do is plug it in to the quadratic formula. Here's the quadratic formula again. Negative b plus or minus the square root of b squared minus 4ac over 2a. So each of those values, the first one is going to be negative b. Now b's value is negative 3. We know negative makes it a positive 3, and that's why it's a positive 3 in that point, in that first number here. Plus or minus negative 3 squared, because it's b squared, and b's value is negative 3, minus 4 times a's value is 3, times c's value is negative 5. So all you're doing is plugging them in. Over 2 times a's value again, and we had a's value being 3. So then you just simplify everything. Do what's inside of the radical first and follow your order of operations. Negative 3 squared is negative 3 times negative 3. This is going to give you 9 when you put it together. So 9 minus 4 times 3, a negative times a positive, that's going to be 9 minus 12. And negative 12 times negative 5, a negative times a negative is a positive. 12 times 5 is going to be 60. So you have 9 plus 60 is going to be the square root of 69. And then 2 times 3 at the bottom is going to be 6. Notice it gets all the way to that step. It combines all of that in one step on the page. There's no shame in working each step out individually on the side if you have to. So now it says 3 plus or minus the square root of 69 divided by 6. Okay? So your solutions are 3 plus, and again, this is it twice, the square root of 69 divided by 6. This is when you want to use those calculators. All of y'all that push 4 minus 8 into your calculators, you're going to quit using it for stuff like that when you start getting things like this. 3 plus the square root of 69 divided by 6. Notice this little wavy equal signs. That means approximately 1.88. And 3 minus that square root of 69 divided by 6 is, again, is going to be that approximate negative 0.88. Okay, here is example number 2. A quadratic equation with one real solution. The question was asked just a minute ago when I took the video off. Do you always have to do 2 solutions? In this case, the first one you did. There's 2 of them, both plus and minus. Watch why there's only going to be 1 solution for this next one. X squared plus 4x plus 11 is equal to 7. Again, negative b plus or minus the square root of b squared minus 4ac over 2a. I'm going to write that on the board. Don't think you have to know that. But after you do it umpteen million times like me, you start to just remember it. Negative b's value, again, it's in the right order. This is a1. This is b4. This is c11. But notice 7 is on the other side. You have to cancel out that 7 by subtracting it on both sides. Now notice what your new c value becomes. It's 4, not 11. So when you plug it in, negative b's value, negative 4, that's b, plus or minus 4 again, squared, minus 4 times a's value is not shown, you got to know it's 1, times c's value. Again, we changed it from 11. We subtracted 7 to get 4. So this is a simple radicand. 4 squared we know is 16. Negative 4 times 1 is going to be negative 4. And negative 4 times 4 is going to be negative 16. So under the radical, you have this. 16 minus 16. That gives you 0. So we're going to have the square root of 0 over 2 times 1 is 2. Anytime under the radical, anytime the radicand is the number 0 like this, it's only going to be 1 real solution. So negative 4 plus or minus the square root of 0. This is just like saying plus 0. It doesn't matter if you add 0 or subtract 0. So what you wind up having is negative 4 divided by 2, which simplifies to the number negative 2. Since the solution is negative 2, when you substitute it back in, you get a true statement. Negative 2 squared is 4. 4 times negative 2 is minus 8, so 4 minus 8 is going to be negative 4, and negative 4 plus 11 is equal to 7. That is a true statement. And again, since it said plus or minus the square root of 0, it doesn't matter if you add or subtract 0, it's still only going to give you 1 solution. Number 3 says a quadratic with 2 imaginary solutions. Okay, we know what imaginary numbers are. They're not real numbers because there's a negative value under the radical, but we can still mathematically work it. So we have x squared minus, let's slide this back a step real quick, x squared minus 4x is equal to negative 8. You have to move negative 8 over by adding 8. Notice when it came to the left side of the equation, it became positive 8. Now you have a, b, and c. A's value is 1. You can see it on the right. B's value is negative 4. C's value is positive 8. So now when we plug it into the quadratic formula, negative b, b's value is negative 4. So when you plug in negative 4, it turns back to being positive 4. This is negative 4 right here, or negative b. Negative makes it positive since b's value was negative. Remember, think opposite with that one. Plus or minus the square root of negative 4, because that's b again, squared, minus 4 times a's value is here is 1, times c's value is 8. And again, I notice a lot of y'all's heads are probably swimming thinking like, how am I going to remember this? You just plug them in. Really, you just plug it in. It is that simple. Over 2 times a's value again is 1. Simplify what's under the radical. Negative 4 squared is 16 minus 4, because 4 times 1 is going to be 4, and you keep the negative. And then negative 4 times positive 8 is going to be negative 32. So what you have is 16 minus 32, which gives you the square root of negative 16 over 2. And that's what we have on our next step. So now notice, you have to have an imaginary solution because of this negative value. And more importantly than that, you're going to have two imaginary solutions because it's both plus and minus. We know that that's 4, the square root of 4 times I. Not the square root of 4, I'm sorry, the square root of 16 times I, which is going to give you 4I. So when we simplify that further, you get 4 plus or minus 4I divided by 2. So your solutions are both 2 minus, they just put the minus first, I'm not sure why, 2 minus 2I, because when you divide at this step, you can divide, 2 goes into itself once, and it goes into 4 twice, and into 4I 2I times. So that's why it becomes 2 plus or minus 2I. The first one is 2 minus 2I. The second one is 2 plus 2I. So when you substitute those values in to check and see if it's true, 2 plus 2I minus 4 times 2 plus 2I is equal to negative 8. When you simplify that, 2 plus 2I, you got to square that. It's going to give you 8I. All we're doing is putting all of this together and foiling it. 8I minus 8 minus 8I. And when you notice 8I minus 8I cancels itself out, and it leaves you with negative 8 is equal to negative 8. That is a true solution. Here's the first checkpoint. X squared plus 3x is equal to 10. The first thing we want to do is move 10 over to where it says is equal to 0. So the equation is now going to say x squared plus 3x minus 10, because you have to subtract it, is equal to 0. Take 30 seconds and plug it into the quadratic formula. Here it is here. Quadratic formula is negative b plus or minus the square root of b squared minus 4 times ac over 2a. Take about 30 seconds. All right, let's see if we have it all plugged into the correct spots. Remember what everything is. The first number, your A value is 1. Your B value is 3. Your C value is negative 10. So all we're doing is plugging it in. Negative B's value is 3. Plus, write that, negative 3 plus or minus the square root. And just draw yourself a big long square root like that. B squared is going to be 3 squared minus 4 times A's value is 1 times C's value is negative 10. And all of that is over 2 times A's value is 1. That's how you should have it plugged in or substituted. So then just simplify the radical. We have 3 squared. We know that that's going to be 9. We have negative 4 times 1 is minus 4. We have negative 4 times negative 10. A negative times a negative is going to be a positive. So what we have is the square root of 49. That was nice of them to give us a number that was a perfect square like that. So negative 3 plus or minus the square root of 49 over 2 times 1 is 2. So we have two answers for this one. Negative 3 plus 7 over 2 and negative 3 minus 7 over 2. And we can't simplify either one of those. Oh, I'm sorry, we can simplify it. That's my mistake. We can go one step further on each one of those. Negative 3 plus 7 is going to be 4 over 2, which simplifies to 2. And negative 3 minus 7 is going to be negative 10 over 2, which simplifies to negative 5. So both 2 and negative 5 are solutions to this equation. If you plug them back into the original one, you'll get a true statement for either one of those answers. Okay? Do the same thing with number 2. Plug the values in. Notice you want to keep a as a positive number. So move 8x and move negative 9 over. I'm not going to erase the quadratic formula yet. See, take about 45 seconds or so. See if you can plug the right numbers in the right spot. Okay, notice with this one, you got to move over. You got to move 8x over to the left. If it was positive on the right, when you move it over, it becomes negative 8x. And you also have to move over minus 9 by adding 9 to 7. That's why if you see in blue, I have below x squared minus 8x plus 16 is equal to 0. That gives you standard form, ax squared plus bx plus c. From there, plug your values in. Negative b is going to be negative 8. Again, negative is positive 8. Plus or minus big long square root symbol. B squared, negative 8 squared. You can go ahead and plug in the value if you want. Negative 8 squared, you know it's negative 8 times negative 8. That's 64. Save yourself a step. Minus 4 times A's value is 1 times C's value is 16. Over 2A again times 1. So now you have the square root of 64 times negative 4. I'm sorry, minus 4 times 1 is going to be minus 4. So that negative 4 times positive 16 is going to be the square root of 64 minus 64. Notice what we have when we do that. Over, it's 8 plus or minus that. Over 2 times 1 is 2. 64 minus 64 give you 8 plus or minus the square root of 0 over 2. And remember, if there's ever 0 as the radical, or the radicand, if it's 0, there's only going to be one solution. It's going to say 8 plus or minus 0, so it's like it cancels it out, over 2. And the solution is 8 divided by 2, which is 4.